Well, good morning, good afternoon, everyone. Thank you for tuning in for the talk. I wanted to talk about something that probably keep a lot of us up at night, our CACD pipeline. We have spent the last decade perfecting them. We have got them deterministic, we have got them fast, we have gotten them reliable, and now we have got a new variable in the mix. The big question isn't just how do we use it, how do we actually make AI work in our pipelines without breaking everything? Because right now I see a lot of teams trying to figure that out, and honestly, it's terrifying. You have a non deterministic, probabilistic agent trying to control a deterministic infrastructure. It's like oil and water. Let's figure that out. So, why am I spending time on this talk? Why involving you in this journey? For the last decade and a half, I have been the guy getting the calls when production goes down. I started my career in an iron ages of ops, debugging, bash mainframe jobs, COBOL scripts. I have lived through every shift, starting from the manual bash script to Puppet, from VMs to Kubernetes. I built infrastructure at Meta where I learned the religion of move fast, especially at scale. I saw what happens when you empower thousands of engineers to deploy constant code. Has scaled platforms at Wayfair handling millions of requests where every millisecond count. Every millisecond is a dollar. Has safeguarded high value transactions at JP Morgan Chase and American Express where the rulers never fail. I learned the cost of caution and necessity of absolute precision. Why my whole career has been one long argument between speed and safety. And now with generative AI entering the ops world, the argument is getting even more louder. Why is this relevant right now? Because we are at a tipping point. Every tool vendor is selling AI ops, every CIO wants Gen AI integration, but nobody talks about the governance required to make it safer. I want to share this car, but I collected and the solutions that I have built so you don't have to learn the hard way. GenOps is how we settle the argument between speed and safety once and for all. So let's look at the industry right now. It's a bit of a paradox. On the left, you see the promises. McKinsey report says 88% adoption. This is how many of us are deploying AI right now, not piloting, not testing, deploying AI right now. We are all chasing that 55% productivity boost that the benchmark as a benchmark that Copilot had promised us. We want the speed, we want to ship features before our coffee gets cold. But look at the right side, the price. Close to $13,000 per minute. That's the average cost of a production outage today. For 2,100 hours. That's just the recorded downtime of a major platform like Jira in 2024. And here is the number that scares me, 7.2%. The DORA report of 2024 says that there is a drop in delivery stability for the teams rushing to adopt AI. Think about that. We are coding 55% faster, but we are breaking production 7% more often. We are driving a faster car, but we have taken off the seatbelts. And the reason is simple. We are trying to fit unpredictable random agents into the pipelines designed for a predictable binary logic. This slide captures most of the things, especially the deadlock we are currently in. This isn't just a technical problem, it's an existential one for DevOps at least. The first one is unpredictability. Let me walk you through an example. Running a batch script today, exit code 0 means successful. Tomorrow, running the same batch script, exit code 0 means still successful. 6 months from now, it is still successful. Exit code 0 means successful. But if you ask LLM to optimize the Docker file 3 times, fingers crossed, you get 3 different Docker files. And in CI/CD pipeline, Variance isn't a feature, it's a bug, it's a noise. The next is the disruption. When a human makes a mistake, they usually break a feature, maybe add to cart button glitch. But when an AI makes a mistake, especially with an infrastructure access, it doesn't just break the feature, it demolishes the whole platform. I have seen this happen firsthand. I was an AI agent hallucinating a Terraform resource deletion. It just looked at a legacy service and authentication handler and decided that it was unused because there were no any recent commits. It tried to delete it. That service authenticated 20 million users. That wasn't a bug. That was a potential region-wide outage waiting to happen. The only reason it didn't happen is because we caught it manually, but that almost moment kept me up for a week. The reconciliation, speed, and safety. So we are stuck here. Security teams try to flip the block switch because they are terrified. Developer find workaround because they need speed. We need to break this standoff. So how do we do this? To fix this, we have a fundamental we have to have a fundamental change in our mental model of what an AI is. On the left is a legacy AI, which most of us might be using, and I'm sure most of us have used it. Copilot or Copilot in IDE or chatbots. It's an external helper. It has zero accountability. If the code it suggested breaks the build, you broke the build. It's not the AI. It's a tool like a fancy spell checker. On the right, where you need to go to GenOps. This is a model, basically a set of system practices or a set of system principles that I suggest. It's a pipeline actor, basically. It has a service account, it has permissions, it triggers build, it can deploy code, it opens its own peer. I know it sounds terrifying, but even LLM a service account, you need a key of the kingdom. But think about it. How do we onboard a junior engineer? We don't just give them a root access on day one. We give them a sandbox. We give them guard. You review every PR. You don't let them deploy to production on a Friday at a 5 p.m. without supervision. GenOps is simply applying the same rigorous mentorship model to our AI agents. We treat them as employees that need supervision, not the tools that needs running. To through the supervision, I call it as 4 pillars of governance. Think of this as a digital nervous system of the AI. Contextualization, which is basically a memory. You use RAG not just for docs but for build history. AI remembers every failure so it doesn't repeat it. It needs to know how we do things here on our trace. We define the blast radius of every change. A high risk means stricter rules. We don't treat a typo the same as a database migration. Canary deployment, we never trust the AI fully. We let it prove itself on a 1% traffic first. Runtime assurance, we need an immutable audit trail, basically for every thought and every decision that AI makes. Well, let's get deeper into each of them. The context aware ingestion. This is basically a flow where we provide the context to AI. The biggest failure or the biggest mode of failure for AI in DevOps is it hallucination. It's the lack of context. How much of information do you provide and how much of information can an AI use when it comes up with its next token? It doesn't know what it doesn't know. If you ask an AI to update the payments API, it uses its training data, maybe the data that it was trained in 2024 or 2025. It has no idea that you have already deprecated the version to work at the last month. So we build a system that acts like an organizational memory. We stack our extracts, build logs, incidents, postmortem, Slack threads, outages. Basically, we vectorize all of them. And when an AI prepares for deployment, we intercept the prompt, we inject the last 50 relevance build, we inject the current infrastructure state. So AI isn't just guessing, it knows, oh, last time someone tried to change this config, it caused a memory leak. We are effectively giving AI a short-term memory to complement its long-term training data. This simple step eliminates about what I call it as 95% of stupid errors. Now let's move on to the next pillar. Context helps, but it doesn't guarantee safety. AI is still probabilistic. It can still take risks. So we need strategic guardrails. We introduce a concept called blast radius score. Before any code merges, we analyze the dependency graph. We ask if the change falls, how big of a crater does it form? Is it just a readme? The blast radius is 1. Go ahead, auto-merge the code. Are you changing a core authentication library used by 50 other microservices? The blast radius is 90%. Block it. This requires human sign-off. We map this to an something we call it as an error budget. So, what is an error budget? Your login service, that's the critical path, has a very tiny error budget, almost zero tolerance. The AI is on a thin leash. Your internal admin tool, like your wiki pages, it has a huge error budget, outage of 1 hour or 2 hours. It's fine. The AI can experiment more freely. And to make this more deterministic, we use open policy agent, OPA to enforce this. The governance isn't a PDF policy document here. It's a code, it's a Boolean gate basically, pass or a fail. Let's talk about the third pillar, deployment. Most teams use Canary, but they use the canary in a very dumb way. They just time, wait for 5 minutes, increase the traffic by 10%. This is not engineering. This is basically a hope. Our canary is an SLO based. We deploy for 1% traffic, a tiny slice. The AI monitor its own rollout. It watches the latency, error rate, CPU, memory, IO operations. If the latency drift by even 2 standard deviations, the automatic rollback triggers instantly. We don't want a customer to complain on Twitter. We don't wait for a pager duty alert. The system kills the bad deployment before human even wakes up. We are shifting from a mean time to repair to mean time of prevention. So the pillar 4, which is governance, and for all the security folks who tuned in, this is how you sleep at night better. In a traditional audit, who means the person who created the change. In GenOps, who is a neural network model that creates a complex nightmare. So we built a centralized model registry. Every single line of a code, every config change generated by an AI is cryptographically signed. We record the exact model version. Was it a GPT 5, 5.1, 5.2, Claude 4.1, 4.5, the exact prompt that was used, the context chunk that was injected? This creates an immutable audit trail. If a vulnerability appears 6 months from now, I can run one single query, show me every service modified by model X using the prompt Y. I can trace the thought process of the infrastructure. Auditors are gonna love this because it actually makes more transparent than a human change. So, this slide is the real story. 55% faster cycle time. And I want to be clear, this isn't just typing fast. This is removing friction. The AI handles the heavy lifting, the config updates, the boilerplate test, the documentation sync. These are the things that drain your senior engineer. At Meta, I have built a tool that turned a multi-hour onboarding task into a 5 minutes automated flow, saving 95% of a reduction in operation overhead. This means that your senior engineers stop being a YAML or JSON spearhead and start being an architect again. And the governance, because policy is a code, it cannot be skipped. A tired engineer at a 2 a.m. might choose to bypass a check. AI cannot. Everyone loves the zero incident. That's great, but look at this number, 14.4%. This is the protection rate. 14.4% of the times AI, despite of all of context prompt engineering, tried to do something dangerous. It tried to push a change that violated an SLA. It tried to merge a dependency with a vulnerability. Without GenOps, this 14.4% would have been an outage. There would have been panic, there would have been revenue loss. Instead, they are just sitting in a log saying log by governance layer. The mechanism for the immune system that is built blocks the virus. This proves that safety and velocity aren't opposite. The only reason we can move fast is because it's safe. There is a safety net of 14.4%. Okay, so what are the next set of frontiers? To summarize why our current tool system isn't enough, static code analysis. This is something that only checks for the code at rest. It catches bad syntax, but it misses the bad intent. It looks for SQL injection vulnerability, but it doesn't look for an endpoint trying to delete the whole table. Anomaly detection is reactive. It tells you the house is on fire after the smoke starts. GenOps is proactive. We act at the moment of generation. We evaluate the intent of the change before it even becomes a pull request. We shift left, past the build, past the commit, all the way to the thought. And this is the blueprint. It's a continuous learning loop, monitoring, basically the eyes. We watch the AI proposals, the system state analysis. We run the blast radius calculation. We check the policy engine, act, which is basically the muzzle or the governance layer. We execute through a safety harness. AI never touches the production directly. Learn the feedback. Every time we block that 14.4%, we feed it back to the memory. The system learns from its own near mistakes. It gets smarter on every failure. So we are getting close. If you leave here with three things, make them these three things. Governance, AI as a pipeline actor, and embracing closed loop systems. So when I say governance, let me talk about an example. Like brakes in a Formula One race aren't there just to make it slow. They are there so that the driver can go 200 miles, 300 miles without any injuries. Governance gives the confidence to speed. The next is AI. Stop treating AI like a text editor. Treat it like a junior engineer. Give it a badge, give it its limit, and audit its work. Embrace closed loop system. The day of fire and forget scripts are over. We need system that self-monitor, self-correct, and learn from their mistakes. The future of DevOps isn't just about deploying code faster, it's about deploying intelligence safer. We are building the nervous system of the enterprise. Let's make sure that it has a brain, not just reflexes. Thank you so much for your time. I'd love to hear your horror stories, success stories in a chat, comment, or on LinkedIn. Let's learn from each other. Take care. Thank you.